So this is a gear case off of anywhere from a 150 to a 225 Johnson or Revenant Outboard. We're going to totally disassemble this, clean it up, and install another drive shaft. In '93, they changed the drive shaft design to a two-piece drive shaft, which made it easier to convert one of these from 25-inch to 20, or 20 to 25, or 25 to 30. And all you have to do is change this. This is it's got a pin inside that locks it in. Now, a lot of times you buy a new lower unit, it doesn't come with a drive shaft or a Johnson Evinrude, and it just snaps in. Unfortunately, it won't snap out, so you have to take it apart. Which the great thing about it is we get to inspect it. So as you can tell, it's kind of dirty, so we're going to clean it before we take it apart, something we do quite a bit. Because as we take it apart, we want it as clean as possible. And we don't want all the dirt and debris inside those gears. So before we take it apart, we have to check the gear ratio. These are generally 1.85 to 1, or in a rare case, they're 2 to 1. That would be like for a V4 commercial. So we want to verify it's the right ratio for the customer. So we mark here, this is the drive shaft. So that has to be turn 1.85 turns to 1. So just short of 2 if it's for the V6, which he has. So I've marked it here, I've marked it there. Put my trusty vice grips on here. So we turn 1 whole turn. And we're gonna go almost to 2, but not quite. Right about there. You see it's not quite there. So 1.85, it's looking like it because it's not getting a 2. That's lined up good there, and that line, so this one is a 1.85 to 1. Now it's not an exact science because there's you have to look up the variations in the manufacturer, and this one is either 2.1, 2.10 to 1, or 1.85 to 1. The 1.85 to 1 fits a ton of motors. So most of them are 1.85 to 1. Just wanted to verify before I do all this work. We've cleaned out the unit so we can take it apart and have as little possible dirt in there as possible. Still needs some cleaning, but I took a video of us blasting that out with a power washer. Another thing you want to do before you take any of your part is inspect it. And without experience, you wouldn't have noticed this, but I did because I do have experience. But another thing you do is check the end play. It's usually that's about 20 thousandths. But see, this is a sacrificial anode. And that goes on the bottom here. So this bearing carrier, which you're going to see in a minute after I take it out, hopefully it comes right out, it's supposed to be on the bottom. Which is like, wow, big deal. Well, guess what? The exhaust comes down from the power head, down through the midsection, and down through there. And that zinc is blocking the exhaust. So it's basically like having a potato inside your exhaust pipe on your car. So this motor, I bet you that would rob 50% of its horsepower. And it would drive a mechanic crazy trying to figure it out if you didn't see it. And if you didn't work with these every day, it would be tough to figure out. Probably can't even find that out on YouTube until today. So I'm gonna use our special tool here after we pull out pull out these 2 tabs. Only these 2 tabs hold the bearing carrier. The bearing carrier is a aluminum pipe inside of an aluminum pipe basically, and it holds the seals and has bearings in there, holds the prop shaft. These 2 little tabs, stainless steel tabs, hold it in. There's notches in there. You pop these out. And away we go. We'll pop them out for you. It's all right to drop stuff inside there because it's coming right out anyways. Pull that out. Launcher going to drop down there. This is a great tool. We use this tool almost exclusively. It goes in like this. Down, got back right off. But if you don't have this tool, this is a really common tool to rent or own. slide hammer, you can put that in there. If it's not stuck too hard, it'll come right out. But we prefer this one. It's a specialty tool from the manufacturer. It makes fantastic tools. This thing has never failed us. And these bearing carriers, you got to remember, it's an aluminum housing inside of aluminum housing, soaked in salt water, heated up with exhaust. So they freeze in there quite a bit. Fortunately, when they put the zincs in there, they don't freeze up too bad. So that's a good thing. That zinc is an excellent thing they did. Boy, this is a little walk here. It's hard. He's loosened it up. It's coming right out. What it does is the center threaded piece pushes against the prop shaft. Now we're getting some water out of here. That's interesting. We had it vented. So that comes right out. So that's it right there. Comes out like that. See, you got your bearings in here. That's that washer that I dropped. I got the back, that's just for the prop shaft, the back part of the prop shaft, the front part right there. These are the seals that a lot of people will try to change without pulling this part off. That's kind of a no-no. So this is not looking good. It's not looking like a good lower unit right now. So we set this aside, pull up our washer. Always try to pick out a landing spot for all your parts because it saves you so much time when you put it back together. Now this is a big mistake everybody makes. There's a thrust washer in there. And I like to take it out with a magnet. You can also take the reverse gear. The reverse gear on a standard rotation motor is always the first one. Get two of these. So now it's time for inspection. By the way, that's not supposed to be there. Yeah. This is really a unique one. So these are called dogs. They engage with a clutch dog and make it shift. Somebody has been in here before, obviously. They put that bearing carrier in and they left a loose bearing inside the lower unit with the gears, and it lodged right there. Well, this may or may not be savable. That might chip off of there, but that's actually pieces of metal deposited in there. See if I have a flashlight in there. The rest of the gears look okay. So the next thing we have to do is see the top bearing there. The smaller gear is the pinion. And we have a special pinion wrench for that. Let me take that out. This is it right there. If you don't have the special wrench, it's 7/8, you can use an open end. So we also have to take these 7/16 bolts out on this top bearing carrier on the top of the drive shaft right here. Take that out. That holds the drive shaft down. As I said, there's a two-piece drive shaft, which you're going to see when this comes off. So this is one of the few times experience helps us out. So I've done this before. That's why we saw the zinc was backwards or upside down. So that's good. So pull this apart. There we go. And they make a special tool to turn this drive shaft, but I actually use an old-fashioned pipe wrench. It actually works better. I like it. We put it, you just got to make sure you put it on the small part of the drive shaft because you don't want to nick it up where the seal goes past. Seal. And away you go. That'll lock up right in there. It's a regular right hand thread. Pull it off. So pinion's all the way out. And that comes out. That is your upper and lower, and you can see that is shot. Got water in it. That's rusted. That's your upper thrust bearing. So this is going to need a new drive shaft. Bottom part, upper part's okay, but as I said, we're converting it to 20-inch, so that's why I got it. We get piles of stuff from marinas. You never know what's going on, so we like to take them apart. So take your pinion out. Let's see if the top shaft wants to come out for us. You got to take the shift shaft out. By the way, if you have a counter rotation lower unit, procedure is totally different. Do not use this procedure on a counter rotating lower unit. You will ruin it. And it's been done by people with 20 years of experience. They don't know that. Screw it up. Let's see if the pinion comes out. Pinion. That is the nut that holds the pinion. Should replace that nut every time you do this. Take the shift shaft out, and then this prop shaft comes right out, hopefully. And that's the lower unit. Shift shaft threads into here. It shifts the dog back and forth. It's called a clutch dog, and engages in these teeth here. For reverse, it kicks into those. For forward, it kicks into those. So the gears look actually okay. Of course, we have to clean them first to check for inspection. And we'll let you know how we make out. But yeah, definitely a sick lower unit. We'll see if we can bring it back from the dead. Interestingly enough, this lower unit didn't only kill the lower unit itself is damaged, but with that exhaust, could have damaged the power head too. I don't know the history. It said there was pieces of a pin or bearing that was molded into the gear or the dog. You see that right there? It's supposed to look like that. It looks like this. Same here. So that's not what that is. That is, and it's the first time I've seen an upside down barrier carrier. And this, somebody welded, I heard of it, they welded onto this dog, because when this rounds out, it'll jump out of gear, go clonk, clonk, clonk. So somebody didn't like the price of new gears, which is about $600, and welded it. That's really half-assed. So these gears are junk. That lower unit was so badly damaged with the welded dogs on the gears. So we were able to pull another one from stock. All the gears were perfect. They're right here. This is the reverse gear. See, that's what they're supposed to look like. Nice, sharp edge there, not rounded off. Everything's in good shape, no rust. This thrust bearing is in good shape. So fortunately, we were, like we said, now this was the wrong shaft length as well. So we were able to just remove this pin, it's a roll pin, and change this upper part of the drive shaft, which is a nice feature. So it's a two-piece. You can see they're not the same piece. So you don't have to do any shimming. These are shims. And there's a special shimming procedure, which we're not going to include in this video because we needed to do it. But if you change the gears or this lower drive shaft, you would have to re-shim the lower unit. Most places don't do it. You can get away with not doing it. We have the shimming tool, so that's probably another video. So we're ready to assemble it. And as I said, I think I want to show you what was wrong with the, this is the sacrificial anode, most people call them a zinc. So this is really nice. These carriers usually come right out because of this zinc. So this goes on the bottom, right here. They had it like this. So if you can imagine the rest of the motor here, the exhaust comes through here, and if you want to put the camera right here, you can see the exhaust comes right through that hole and down and out through hub exhaust. So this is basically exhaust pipe. So by doing that, that motor probably didn't go very well at all. Probably, like I said, lost 2/3 of its horsepower. And that would drive a mechanic crazy right there, because you'd never think to look there. I've seen this before with blocked exhausts. They go crazy rebuilding carburetors, checking injectors, anything. And it's something like that. It's the last thing you look for. You'll never even see it in the troubleshooting guide. Rare thing, but you do get blocked exhaust. Okay, we've gotten the pinion gear in here. We've got the forward gear in, so we're ready to put it all together. So if you don't know, the clutch dog moves back and forth between the forward and reverse. You see it move up? Boom, boom. So on a standard rotation, non-counter-rotating lower unit, the reverse gear is always closest to the propeller. That's this one here. It doesn't have its heavy-duty bearings on it because it's only being used less than 1% of the time. So we drop this in. It has a couple of bearings in it. It's a thrust bearing. Make sure they're in there. Drop this in. You see the dogs go into the clutch. That'll cover up that pinion gear. The smaller gear is always called the pinion gear because it drives both forward and reverse all the time. So that goes in there. It's nice to keep it nice and vertical like that, so you can drop everything in, everything lines up. You can drop this in here. There's a seal here, it seals here where they've been inspected. They're in great shape. Drop that in there. And again, the bearing carrier on the bottom. Then we tap that down. Drift. I like to use a bronze drift on this so it doesn't break anything. You can tell it's lined up good because these little tabs that hold it together. If it's not in far enough, these won't set in. Sets in like that. It's nice and flush. We're ready to put our bolts back in. Then we'll pressure test it. We have completely reassembled this lower unit with the shorter drive shaft. So you can put this on as 20-inch motor. It's just better than a used one because all the gears are thoroughly inspected. They're in perfect shape. But the last thing we want to do is we pressure test the lower unit. A lot of people, they talk about just the prop shaft seal, that one be here. But there's about 5 other places it could leak. It could leak at this gasket. There's a seal around the shift shaft housing. That could leak. There's a seal underneath this water pump. That could leak. There's a big O-ring around the bearing carrier, which we showed you in a previous video. That's right. I'll show you right now. It is right here. That could leak. So you pump this. This is just an air pump. Unfortunately, if you're doing this yourself, you probably don't have this. They do make some inexpensive pumps online you could possibly buy, but it's pretty critical to do this. So you pump this up to, I'll pump this up to 15 pounds. That's kind of standard for Johnson, Evinrude, and Mercury. 15 pounds for 15 minutes. So you just pump it up and make sure that doesn't come down. Put it aside for 15 minutes. Clean your tools up. And it's already passed. If it doesn't pass, what you can do is you can take a little spray bottle of some soapy water or some cleanser. It'll bubble up wherever it's leaking. Then you know to just fix that seal. Another thing you can do is you can put it in a big barrel of water and you'll see it bubbling. It's already passed. So what's going on here is wherever there's a rotating shaft or even a shift shaft, there are back-to-back seals like this. These are drive shaft seals. So on Mercury and Johnson Evinrude, 90% of the time, they're back-to-back. Yamaha puts them the same direction. So does most of the Japanese ones. So they're like this. So when I pressure test a Yamaha, you don't want to go to 15 pounds. You would go to about 11 because they're in the same direction. They can leak a little bit. But so you just cut down on your pressure, on your gauge, and you're good that way. So